the April 2017 remote sensing wildfire workshop. We're still collating all the results and working on proceedings. So this is a very preliminary update. But I just wanted to keep you guys in the loop. So I'm going to provide some background information about what that workshop was about, where it fits in the IARPIC process and the collaboration teams, and a little bit about what we learned and what our next steps are going to be. Okay, come on, you. Oh, there. So just a little bit about us. I'm the coordinator for a unit here at UAF called the Alaska Fire Science Consortium. We're funded by the Federal Joint Fire Science Program. Their money comes from Department of Interior and Forest Service, hence the term joint. And they fund it in the past almost 20 years, they have been funding, varying, of course, with the budget, about $9 million a year in research that in wildland fire that has applications directly to management problems. They started about 10 years ago. They started a significant piece of that program is a network of what they call fire science exchanges. And the Alaska Fire Science Consortium is one of those exchanges. So at this point, every region in the country is covered by a fire science exchange, and we are the one for Alaska. Sarah Trainer is the PI, Scott Rupp is the co-PI, I'm the coordinator. And then one of the things that I think is really important for folks to understand about AFSC is that we have two retired agency managers who work with us on a very part-time seasonal basis, and they have different and complementary expertise. And our ability to draw on their expertise is so important in the kind of work that we do in terms of making sure that the work that we do is relevant to the region's managers. So those two people are Randy Jant, who I think most of the people on this call know. She is a longtime fire ecologist in the state of Alaska. And the other one is newer to this group, and that's Robert Zeal. He goes by Zeke. He's a national level fire behavior and weather analyst and works at a very high level as a fire behavior analyst. And he got interested in the Alaska problems a couple years ago and now works with us on a seasonal basis. He was supposed to be on this call today, but he is in his off-season time and he's out buying a trailer. So that tells you that we can't always count on these guys, but they are amazing. Their expertise is amazing in terms of making our work relevant. I also want to, while I've got this slide up, I just want to put one little piece of news in everybody's ear. If anybody cares about the Joint Fire Science Program and what they have been able to do in the last few years, the FY17 budget that was enacted actually cut the Joint Fire Science Program by about $4 million. And they are, this in FY17 are only going to be able to fund about half of the research proposals that they were planning to fund. So they're going to be funding about 14 projects instead of 26. They are continuing to fund all the fire science exchanges at the full level. The President's FY18 budget actually zeroes out the Forest Service contribution to JFSP, so their and cuts the DOI contribution in half. So they would go from an effective budget in FY16 of $13 million to in FY18 $3 million. Just wanted to let folks know about that if anybody has any interest in communicating with anyone who can improve that situation. They have a demonstrated record of effectiveness. Anyway, back to IARPIC. AFSC was quite active in supporting in the past round of IARPC. We had a wildfires collaboration team, as I think everybody on this call knows, and AFSC was quite active in supporting that. Randy actually was the co-chair of the wildfire collaborations team. And here's an example of a poster that we presented for the IARPC team at the Arctic Observing Summit in March of 2016. And the project I'm going to be talking about today is really a contribution to IARPC. So just to give you a little bit of background on fire in Alaska and the history, I think most people here know that the record of acres burned in Alaska in the last 60 years is extremely variable. So a few extreme years interspersed with a lot more low or sort of normal years. At this point, the management community is starting to call 1 million acres a normal fire season in Alaska. And as you can see, if you look at this record, it looks like the number of large seasons seems to be increasing since about 1980, 1990, something like that. It's awfully difficult to tell with a record this short and this variable, but the general feeling is that climate change is having a very significant impact on fire season and acres burned in Alaska. 2015 was a really notable year. It's the second highest in terms of acres burned, and was really quite, as the managers say, it was quite a thrash. And it was quite a thrash because of some pretty extreme fire behavior. This is actually a picture of the Fort McMurray fire, to make the point that this kind of extreme fire behavior and increased fire activity is something that we're seeing across the north. So it was in Alberta in 2016, in the Northwest Territories in 2014, in Alaska in 2015. And all of these parameters on the slide seem to be changing with climate change, and all of them affect fire activity. And this is to make a point about 2015, which is that if you look at the area that it's got kind of a little yellow shading over it, that's when the bulk of the acres burned in 2015. This is cumulative acres burned 2015 versus 2004, which was the actual record season, to just show you the sort of shape of how rapidly the acres burned in 2015. Like I said, the managers said it was quite a thrash. And if you look at that we burned almost 4 million acres in right around 3 weeks. And that was really not something that people anticipated was possible. That was partly because we had a lot of ignitions, a big lightning bust that started about 300 fires in a very short period of time, but it was also because the fuels were extremely preconditioned, very dry. And so fire growth was extremely rapid, more rapid than people were expecting. And that was really due in large part to the next slide, which I think is really important for this audience to understand. People tend to talk about wildland fire as a forest fire, but actually in boreal and tundra systems, it's really dependent on the surface of the understory. So this is a duff plug pulled out from a boreal system with the layers of live moss at the top moving down to mineral soil, and all of this material in between is actually what can carry fire in boreal and tundra systems. And it's actually very dryable. It dries extremely quickly on a warm, hot day. And that's a lot of what happened in 2015. So it's important that you recognize that this audience, as they're thinking about terrestrial ecosystems, recognize that this is a really important part of fire danger. So after 2015, that, like I said, the managers said it was a big thrash. It was a big thrash. And, you know, Alaska faces some significant management challenges just because of our size and distance, and also because of the fact that we have such a limited road system. So when we sat down after the 2015 season and talked about it, managers were really challenged to think about how to move forward into a future that was going to look more frequently like 2015. How are they going to increase their operational efficiency in a situation like this? And one of the only places where they felt that there was any kind of room for improvement in their operations was to do a better job using remote sensing technologies. In an operational sense, really the suppression agencies here, the managers, are really primarily using MODIS and VIIRS for active fire detection. And there's a lot of room for growth in other areas of fire management, in understanding weather and risk forecasts better, much better understanding of smoke dispersion, some of the factors that are leading to these extreme events, getting a better handle on fuel moisture in those deep organic layers that I showed you, and then trends over time. So they felt like there was a lot of opportunity to improve operational efficiency through understanding what opportunities were out there in better using remote sensing. So on their behalf, and using the IARPC Wildfire Collaborations team as part of that, it's part of the bureaucratic underlying of our effort. We wrote a proposal to the NASA Applied Sciences program and got funded for a workshop. The general design of the workshop and the motivation was very much designed around, we used the 2013 workshop that was organized by Vladimir Romanovsky here using the National Academies, that was focused on using remote sensing in permafrost, and we used that event and its outcomes as a model for this. So here are the members of the workshop organizing committee. We ended up having an extremely, I think, extremely successful event. We had an awesome organizing committee, people from all over the country, and representation from Canada, and really some key people. And we were overwhelmed by the response to our call for abstracts. Here are the goals of the workshop. And we kind of divided up the discussions at the workshop into pre-fire, so potential fire risk, how can remote sense data help us get ready, understand fire danger and risk ahead of the fire. Then what tools would be best during an actual active event. For ongoing fires, there are a lot of questions there. And then looking at post-fire effects, what kinds of data would be most useful for the problems that managers face in the post-fire environment, being able to predict successional trajectories, erosion, active layer changes, things like that. So here's a picture of the workshop. We had a 3-day workshop at the beginning of April here at UAF. We had 100 people register. We had 34 talks and 16 posters and 3 panel discussions. One of the things I wanted to let you know was that we did a pre-workshop webinar, because many of these presenters were new to fire in Alaska, really didn't know that much about the system. A lot of these people were national and international resources in remote sensing and just not as familiar with our problems. So we talked to them about that ahead of time, and that seemed to be very helpful. So we didn't spend a lot of time at the workshop itself sort of doing that introductory stuff. And then we also were able to capitalize on a unit that NASA funds called RSET, Applied Remote Sensing Applications Training, and they came up and did a hands-on training session before the workshop for us. So we were real happy with that. And the 3 panel discussions that we organized featured both scientists and managers talking about the problems that they had heard. And I think that was a really valuable part of the workshop. So here's the discussion. I'm pretty sure this is Postfire, the Postfire panel. There's Jen Roback, who's on this call. All the materials from the workshop are online at our website. So there are the agenda, all of the background material that we provided participants, the all of the presentations, recordings of all of the presentations, and recordings of the discussions are all there. So I would refer people to that if they want more details. Right now, Randy, Zeke, and I are working on putting together draft proceedings and recommendations from the workshop, and we'll be providing those as after the workshop participants have an opportunity to review that material. Here's some of the outcomes that are the most relevant to this audience. There's a lot of opportunity for improving vegetation and land cover mapping, and that would need to be coordinated with Landfire, which is the national system that fire managers use to look at vegetation in the context of fire management. There's a lot of opportunity to improve, to tune spectral indices like NDVI and Delta NBR to northern systems. Those are essentially developed for southern latitudes. There are some good opportunities to improve our looking at soil moisture over these broad scales with SMAP. Even with the sensor going down, we think there are some good opportunities there, and there's a team at MTRI working on that. There are probably some good existing snow cover products that we're not using because they are a little difficult to get into our operational environment, but we expect to be working on those. There are some great science questions about burned area mapping and fire return interval, and the perceived increase in reburned areas. So fires burning into areas that recently burned seems to be on the increase. So looking at those questions over time would be really valuable. There's always a need to do something to get an algorithm that would help us map old growth lichen, which is very important for caribou forage and is very vulnerable to fire. And then questions of carbon consumption and emissions, which I think Brendan's going to be talking about at least a little bit. Then there are the primary opportunities for collaboration that came out of this that are relevant to this group are worth working with the forest inventory analysis effort in interior Alaska in the coming years to get some ground truth data. And then, of course, above, which has there are a lot of opportunities to collaborate with above to move some of these issues forward. And then I wanted to also let you guys know that there's another group that has only been minimally folded in here. I think some of you know the name Vince Ambrosia. He was active in the wildfire collaborations team. I don't know how active he's going to be in the terrestrial ecosystems collaboration team, but he and Everett Hinckley of the Forest Service run a little informal group called the Tactical Fire Remote Sensing Applications Committee. And they just had a meeting a couple of weeks ago, and that's actually a group that communicates between the classified remote sensing community and the operational fire community, and they're working on a lot of the same kinds of problems that we are. They work both classified and unclassified, and as part of the recommendations out of our workshop and also their meeting of a couple of weeks ago, they're leading development of a joint requirements matrix to look at what are the problems, to start looking at specifics about questions of things like scale and latency for specific products that fire managers would be interested in using. So that's currently in draft, and we'll be working on that. And I just kind of wanted to make one more point about this, and then I'll be done. One of the things that came out so strongly here is that there's no shortage of great ideas from the research end for tools that could be used in operation. And we all kind of think about that problem as if there's a nice pipeline moving in one direction from research to operations. But in fact, when you start thinking about it and trying to do this work, what you discover is that the water in the pipes needs to flow in both directions, because operations really needs to be getting information back to the research project before you can really make any kind of product that works for the operational community. I don't know if this analogy is working for anybody, but we talked a lot about plumbing at this meeting. That ended up being the analogy that we ended up using of sort of the manager confronted with a whole set of many tools, many potential parts to make a working plumbing system, but really needing to have a good sense of an inventory, and then the plumber needing to have a good sense of sort of the problem that they are trying to solve. Where does the water need to go? How often does it need to go? How hot does it need to be? Questions like that. Do you need the putty, or do you need the drain unclogger? So we talked a lot about that kind of the essentially bureaucratic problem about communication between these two communities, which is not going to be solved by one workshop. I also wanted to let you know that Zeke and I are going to a Canadian meeting with very similar goals and objectives next week in Montreal, and we'll be presenting preliminary outcomes from the workshop there with more of a focus than I was able to do today on fire management problems. So just a reminder that all the materials are online on our website, so feel free to spend some time looking at those, and there's my email. So I'm happy to answer any questions.
Great. Thank you so much, Alison. I really appreciate that. And I think this really represents one of those tremendous opportunities for the terrestrial ecosystems team to step the work that we're doing down to the level of actual operations. So again, it's really great to hear what you had to say. So we do have some time for questions. You can either put those into the chat box for us, or you can actually unmute your line and ask a question directly.
Hi, Alison. This is Brendan. That was a great presentation. It was really good to see you too. I wanted to be able to attend the workshop, but I couldn't.
I know we missed you.
Yeah, I sent Sander in my stead. You sounded like you had a great time.
Yeah.
So yeah, it was good to see kind of what you focused on. I like the plumber analogy, and it got me excited about what we can do in the future. I had two just kind of specific questions as you were showing the slides, but I didn't want to interrupt you. One was, I thought it was really neat to see the seasonal progression of the fires in Alaska from 2004 and then 2015 and how that differed. And I was just curious, have you looked at like 2005? It was slightly smaller in terms of burned area compared to 2015. Did it have that same sort of rapid accumulation as did 2015, or was it more like 2004?
No, it was more like 2004, and that's one of the things that we're starting to think about and talk about internally, is this concept of the sort of pathway to the big season. That there seem to be a couple of sort of tipping points in a season. So that could lead and that could line up. So that there are different curves, and I've got a figure somewhere, but I probably can't find it while I'm online. I'll send it to you, and I'll put it up on the team page, where we've lined up several of the most recent big seasons on that cumulative, and the answer is some seasons start with a big spring, and then some seasons have that rapid growth in the middle, and some seasons are like 2004 and 2005. They just never seem to end, and they grow and grow into early September. And so far, every season that has been a big season, one of those things has been true, or maybe two. There hasn't been a season where all three of those growth contributors have lined up, but
Right.
we see the possibility for the mega season, the 10 million acre season, as because all of those, what we think is that all of those tipping points, the spring, the center, and the fall, all of those are related to climate change, and sooner or later all three of them are going to line up. It's just kind of a question. It's kind of a question of time, and we have a figure sort of thinking about that.
Yeah, it'd be interesting also to see the progression of the ignitions, because so one of the Sander might have shown this at the workshop, but one of the things he's been working on, this is a paper that's coming out in a couple of weeks in Nature Climate Change, so we're excited about that. But it was focused on the large fire years in Alaska 2015 and then Northwest Territories 2014. And
exactly,
one of the many things there is that the majority of the actual ignitions were in June, whereas most of the burned area was in July. So that, I feel like that could be a point of leverage, thinking about future and how to better, potentially more efficiently use the resources, is if we can figure out a way to project which fires are going to get really bad, focus on those. And I don't have enough sort of understanding to say anything more intelligent than that, but yeah, the ignitions start well before most of the burned area actually happens.
Yes.
And you're probably well aware of that, but.
Yep. But it's good for this audience to be aware of it. Yeah. No, ignition is huge, and yeah, the essentially uncoupling of ignition and emissions and then growth. Yeah. Interesting.
And the other small question I had, when you had your areas for improvement, one of them was better spectral indices for Alaska or boreal forests in general. Did you mean, were you thinking better relating the indices we have to ecosystem properties on the ground, or actually coming up with new, better indices themselves?
No, it would just be helpful. I think there are some people who are thinking that they could come up with new indices, but it would be a great start just to have a better, essentially ground truthing calibration of existing indices. There's a fair amount of mistrust in the management community for the existing indices. I mean, they're developed in the lower 48, and it's really unclear how well they work here. And a systematic effort to look at that would be extremely helpful. So that's a great opportunity. It seems to me that's a great opportunity for above.